Our next pattern are perfect squares. And there isn't much of a pattern here because we're not going to do it too much differently. If you have a trinomial and your first term is a perfect square, your last term is a perfect square, and if I take the square root of those and multiply them together and multiply it by 2, I get my middle term. I can factor that into a perfect square. So for example, x squared is a perfect square, 25 is a perfect square. The square root of 25 is 5, and 5 times x is double that. I get 10x, so that'll be x plus 5 times x plus 5. You don't really have to notice it that much because anytime I have a trinomial, I think what I'll do is I think the easiest way is to make the box. And I'll put 4j squared in my first box. I'll put 16 in my last box. Notice these are perfect squares. So I'm wondering, I'm going to guess and check and see if this is a perfect square. Well, what's half of 8? Half of 8 would be 4. So I don't have to do the AC method if it's a perfect square. Now remember, I'm guessing. We'll see if this works out. Now I know these add to 4j squared plus 8j plus 16. I can see that. Well, let's factor it. Let's see if it turns out. What goes into 4j squared and 4j? Well, that's 4j. What goes into 4j and 16? That's positive 4. What goes into 4j squared and 4j? Oh, 4j, isn't it? And then positive 4. They're the same, aren't they? So this does factor to 4j plus 4 times 4j plus 4, which I'm going to say squared. Take it times itself. So if you have a perfect square for your first term, a perfect square for your last term, guess to see if it factors. If it does factor, then it's a perfect square. If it doesn't factor, then go back and do the AC method. Now let's take a look at this one. Once again, I notice that I've got 36x h squared is a perfect square. 1 is a perfect square. So let's try that and let's see if it is a perfect square trinomial. So 36h squared and 1. Half of negative 12 would be negative 6h and negative 6h. So factoring in vertically, I get 6h minus 1, because the only thing that goes into 6h and 1 is 1, but the leading coefficient is negative, so I want to factor it in negative. Going across, I'll get 6h and minus 1 again. Oh, that works out then, doesn't it? So I get 6h minus 1 squared. I think the reason we did this problem was because the middle term is negative. So if my middle term is negative, I'll have a negative here. Notice on example 4, my middle term was positive, so I have a positive here. That's the pattern we're looking for.